whatever the case may be. We are back and better than ever, and today we are going to work with exponential equations. So easy. It's the predecessor of working with logarithms to solve those that are more complicated than what we're doing today. Let's get right to it, shall we? An exponential equation is an equation in which the unknown occurs as part of the index or the exponent. So, anytime you have your variable as an exponent, it is an exponential equation. And clearly, if I have something like this, if 2 to the x equals 8, and then I rewrite the 8 as 2 cubed, if you couldn't see it here, then the x must be equal to the 3. The lesson being is if I have the same base and an equality with the same base, then the exponents must be equal to one another in order for the equation to be true. Let's give it a try, shall we? 2 to the x equal to 16, so I'm looking, since I have a base of 2 here, I'm looking to write 16 using a base of 2. 2 to the x is equal to 2 to the 4th. Holy smokes! Yes, 16 is equal to 2 to the 4th, therefore x is equal to 4. And perhaps you could just look at that and do that, and that is fine as well. But with something like this, maybe you can't. So my base here is 3. I can't do anything with it. So 3 to the x plus 2 power. And the 27, I'm going to write 1 over 27 is 1 over 3 cubed. Yes. And then to have the same base, I need to rewrite 1 over 3 cubed as 3. This is a 2, sorry, as 3 to the negative 3. So since the bases are equal, then I can set the exponents equal to one another. X plus 2 must be equal to negative 3, so x must be equal to negative 5. And let's see if that's true. So if I let x be negative 5 here, I would have 3 to the negative 5 plus 2 equals 3 to the negative 3. Equals 1 over 3 cubed, equals 1 over 27. Boo-yah. There's my check. All right. Solve for x. Sometimes the base isn't as obvious as it first might seem. Both 4 and 8 can be written as bases of 2 or with a base of 2. Rewriting 4 as 2 squared to the x power. And then rewriting 8 as 2 to the 3rd power using my laws of exponents. 2 to the 2x then is equal to 2 cubed. 2x then is equal to 3. Since my bases are the same, the exponents must be equal. X equals, x equals 3 halves. Over here, it looks to me like my base is going to be 3. I'm going to rewrite 9 as 3 squared to the x minus 2. And that is going to be equal to 3 to the negative 1, rewriting 1/3. And then again, using my law of exponents, this becomes 3 to the 2x minus 4. Don't forget to multiply the 2 by the negative 2 as well. It's 2 multiplied by the entire exponent, not just part of it. That must be equal to 3 to the negative 1. 2x minus 4 equals negative 1. Negative 1, add 4 to both sides, 2x is equal to 3. What a coinkydink. X is equal to 3 halves once more. And so now we're going to solve this for x. And this is where we can put this in the form of a quadratic equation. Anytime you have a trinomial, it just might be that we can write it as in the form of a quadratic, factor it, and then use our very favorite ZPP. Yeah, you know me. That's right. So, okay, I need to write this as something squared, and that something needs to be 2 to the x because there's nothing else I can do with this middle term. So I'm going to rewrite 4 as 2 squared to the x power plus 2 to the x minus 20 equals 0. And I'm not quite there yet. I need this to be 2 to the x. And I'm going to go step by step here. Maybe you see it right away. 2 squared to the x is equivalent to 2 to the 2x, multiplying our exponents, plus 2 to the x minus 20 equals 0. And then I can write 2 to the 2x as 2 to the x squared, plus 2 to the x minus 20 equals 0. And now it's factorable, but some folks don't like working with the exponential expression. So if you don't, you can simply let a variable represent the exponential expression. So let something like n equal 2 to the x. Then I have n squared plus n minus 20 equals 0. And that factors into n plus 5 times n minus 4 equals 0. And using ZPP, that means n could be equal to negative 5 or n could be equal to 4. And then substituting back in, n is equal to 2 to the x power. So I would have 2 to the x is equal to negative 5, or 2 to the x is equal to 4. And I can throw this one out because there is nothing I can raise a positive number to and get a negative number. So there is no solution here. And here, of course, 2 to the x, I'm sure you know that x equals 2, but we'll just go ahead and write it out anyway. 2 to the x equals 2 squared, same base, therefore the exponents must be equal, and we get x is equal to 2. All right, so I thoroughly enjoyed that. I'm sure you did too. And with that, I am going to say that I am out.